So I've opened up these notes. This is the one that's about the non-bilateriates for animals 1. And then I have my phyla here. You see I've just used my zoom function to get into where I can see it. And the nice thing here is that you should be able to move so that you can go across but still see what in the world you're trying to answer the question. So let's just do some cnidaria. So nido means stinging. I asked about sites. Site means cell. Presumably you maybe know that by now, but you can see nidocytes, stinging cells. So site, cell. Common name, phylum Cnidaria. See here, cnidarians is what we're using. Nothing fancy. Defining characteristic, so we've got those stinging cells. The big deal of them. Hence their name. Okay, phyla, subclasses, and clades. Okay, let's go. Here we go. Classes, examples, and clades. So we've got clades, Anthozoa, Medusazoa, and then we've got these classes, Hydrozoa. So I'll put those in. Hydrozoa. We've got Scyphozoa, jellies. And we have Thozoa. Just for my own knowledge, so I can use this to study later. Okay, now, is it in metazoa and such? So what I would do here, as I go back to my phylogeny that I have, and this should tell me a lot of information here. So in metazoa, yes, all animals are in metazoa. So if I go to the drop down, I can do the X. In eumetazoa, are they in true animals? Yes, because they have true tissues. Are they in bilateria? We see bilateria here. Cnidaria are outside of bilateria. Spiralia, Ecdysozoa, Deuterostomia are all inside bilateria, so we know it's not any of those. Okay, so we'll go back to our cnidarians. Okay, so we say how many layers? Diploblastic. Okay, so when we there we go. Diploblastic. Development. I guess I do need to give you that information, but well, let's move on for now. We said radial symmetry, body plan. Radial. Body cavity, what do I have? There's no coela, so it's, yeah, that's only a eumetazoan seal, so not applicable. Digestive system, so let's go look for something that says digestion. Okay, it's about digestion. Okay, here we go. Digestion, no intestines or stomach, gastrovascular cavity, and you can see how that works there. So digestive system is GV, cavity. Circulation, so let's look at this. Circulation must get nutrients, no cardiovascular system. It's under gastrovascular cavity. So that's what we have here, diffusion and gastrovascular cavity. Nervous system, so let's find that. Muscles and nerves, so we see blah, blah, blah. Nerve tissues are primitive. Centralized nerve net, so that's our nerve net here. Excretory organs, let's see if we can find something about those. Here's a hydrostatic skeleton, so we can go down to support, actually. So support, hydrostatic skeleton, no shell. Gas exchange. So it's no cardiovascular system. Tractile cells, simple receptors, primitive tissues. No intestines or stomach. Yeah, it doesn't really have any systems. sort of what we're seeing here. You know, no circulation, right? So gas exchange, looking like that. That's just diffusion across the body wall. Gastrovascular cavity. Excretory organs, fusion. Osmoregulation. Diffusion. No segmentation. Muscles. Let me see here. It tells us about primitive tissues, actin-myosin nerve filaments coordinated, so that's muscles. So it looks like we have some pretty simple muscles and contractile cells going on. Simple muscles. Locomotion. Let's see here. This is swimming, sessile. So we can just write quickly like Medusa contracts L-shaped body. Polyps are sessile. Right. Reproduction. Let's see, free swimming, blah, blah, blah. Oh, here we go. Okay. Alternate polyp and medusa life forms. So you can see this is sexual and asexual reproduction. We don't need sexual, asexual. So we're looking at both. Actually, at least asexual for some of them. Life cycle info, not too worried about that. That's good. Oh no, this is, I've gotten over to platyhelminthes. All right, well maybe that's why. Okay. There we go. Ah, so polyp. Sessile means doesn't move. Contracts. L-shaped body. Sort of drifts along there. Simple muscles. No segmentation. And then of course I'd move this over. So forth. Let's see. Development, you don't know that. I didn't tell you. So that's on me to tell you that. But okay. And then of course I have to move these over since I messed that up. That's like kind of how I do it. And if if you end up with some stuff you can't find, then basically you just do the best that you can. Notes, I got nothing. And then these here. Okay. So that's basically what I'd end up with Cnidaria. Sure, we have no other information. Okay. So then let's say we're in Lophotrichozoa now, or Spiralia, and we want to go to, let's go to mollusks. So I'm going to find the mollusk section. There we go. All right. So I'll answer these as we go along. Defining characteristics. So we've got those marked classification criteria. So that's what we're looking at. We've got a muscular foot. We've got a visceral mass, internal organs, and we have mantle. Okay, here's some examples of them. Oh, here, classes of phyla. So I have 4 here, so polyplacophora or polyplacophores. Looks like we've got gastropoda, bivalvia, and cephalopoda. Okay. Which ones is it in? So again, we can go back to our phylogeny. Actually, do I have it before this? I do. Before here. So is it in metazoa? Yes, because that's all animals. Eumetazoa, does it have true tissues? Yes. Bilateria, so we see we're inside, where are we at now? Mollusca, bilateria, yep. Spiralia, mollusca, spiralia, yep. Ecdysozoa and Deuterostomia, those are 3 are mutually exclusive, so no. Tissues and germ layers, so all of the bilateriates are triple blastic, so they all have their 3. Mollusk development, I'll have to tell you that. Actually, take that back. It's in the other animals one. So intro to animals. Okay, here we go. So you can see protostomy, deuterostomy. So we're going with mollusca. Most are protostomy. Mostly protostomy. Symmetry. So we know that this is in bilateria, so therefore it must be bilateral. Symmetry. Body cavity. These guys are here we go. So coelomates, basically pseudocoelomates are Nematoda rotifera. The acoelomates are platyhelminthes. So everybody else is a coelomate. So mollusks are coelomates. Eucoelomate. Digestive system. Okay, let's go back to our mollusks. Go. So we see here, radula, they scrape up food, internal organs, and if we look through here, we see, oh yeah, we see that digestive tract, right? There's the mouth where the radula scrapes it up in the anus, so that means that it's complete alimentary canal. Anus at the end of the body. Circulation. Here. Open circulatory system. The interesting thing is, let's look at these individually. So I'd say open circulatory system, and that's like until I got to here. And then I would see, oh, cephalopods have a closed circulatory system, which is why there's 2 separate here. So the sessile pretty much have open circulatory, yeah, open, and then we have closed in the cephalopoda. And why? Facilitate movement of gases, waste, and fuel. That makes sense if it's moving fast. Nervous system. Large brains, so if we're hearing stuff about brains, Centralized, cephalized. Let's see. Not dorsal though, ventral nerve cord. Here we go. Nervous system. Sessile simple systems, complex, highly mobile, complex systems, so ganglia, brain. Interesting. Definitely ventral nerve cord, definitely not a nerve net though. And then I tell you these two nephridia for those. Gas exchange. We're looking here. We've got some. Here we go. External body surfaces of function is gas exchange. It's gonna lead a. Here we go. Respiratory surfaces. Let's see, we have. There's nephridium. We've got a gill in here. So at least some gills. Locomotion, paired gills, suckers, blah blah, siphon the mantle. Gastropods. Let's see, more gills talked about here. Yeah, so we definitely have some gills going on. Oh, just the gills. Like snails and stuff. So I know that that says mantle cavity is lung. Okay, structural support. Well, I know a lot of these guys have shells. Not all of them, but many of them do. No exoskeletons or endoskeletons, so hydrostatic skeleton must be with shells. Segmentation, no. Muscles, we have well-developed muscles. The only ones without well-developed muscles are muscular foot and all that stuff, are the diploblastic ones. Well-developed. Locomotion, swim, crawl. Both those. Reproduction here. Many mollusks have different sexes. Some are hermaphroditic. Looks like those are all sexual though. Hermaphrodites still do sexual reproduction. Life cycle, not worried about that. Okay, so that's what I'd fill in for mollusca. Then you do something like Annelida. Go. Annelida or segmented worms. Defining characteristics. They're the only ones that are segment worm body with segments. Oh yeah, and as I went along, we did see these. So cephalo was defined in there as head, gastro is stomach, bias too. That's how these names come about. Examples, well, we look like we have leeches and earthworms. Got these polychaetes. Actually say that in here anymore. It's an old classification. So just put those in there. Metazoa, yes, all of them are in metazoa. Eumetazoa, yes. Bilateria, yes. Spiralia, we look at our phylogeny, yes, can't be in those. Tissue layers, we know all of them are triploblastic. Development, go back and look at this deal here. There we go. What does it say about Annelida? Most Annelida protostomy. Symmetry, we know it's bilateral, so it has to be bilateral. Body cavity, everything is eucoelomate, except for, I said before, platyhelminthes, Nematoda retifera, rotifers. Digestive system, so go back here, and you know from the earthworm that it, poops out one side and has a mouth, but if we see here, true coelom. Hydrostatic skeleton, so let's put that in. Structural support, Annelida. Hydrostatic skeleton. We've got nervous system, ganglia, ventral nerve cord, so we can put that in. Nervous system, ganglia, ventral nerve cord. Got body, digestive tract complete, so it's open at both ends. I think it's at end of body. Circulation, closed circulatory system, closed. Excretory organs, metanephridia, osmoregulation, nitrogenous waste. I guess I'd have to leave that one blank. I think that's metanephridia as well. Gas exchange. There's nothing in here about anything gas exchangey. So it probably means, oh, here we go. Parapodium have gills. So let's say water species or aquatic, whatever water species, probably gills, land species, body wall. Yeah. Segmented, yes, that's one of our points. Muscles, we saw that with the crawly guy. They have well-developed muscles. Well-developed locomotion, crawling. Oops. Hello. Okay. I don't know what's happening. There we go. Crawling. Peristalsis. It's like inching along. We also have swimming. This is over here. Parapodium for gas exchange. This is gills. Did you gas exchange already? I did. Gills. It's like Parapodia. Reproduction. Hermaphrodites. Sexual reproduction. Hermaphrodites. Uh, Sexual life cycle info, nothing really there. Notes. That's all I got for that. Okay, then you just go, do a similar kind of thing for the other ones, and whatever you can't find, you just leave. Chordata should be pretty straightforward. Cephalo. Yeah, and you just use the notes in the phylogeny for that as well.